Think of a move module as a self-contained micro blockchain. It holds all the logic types and constants that work together, then exports only the pieces you mark public. The chain stores your module at a fully qualified address like 0x123 ::SUI pulse token, making it globally unique. Published bytecode is immutable, so a module's public API is a promise you must keep, or version later in a fresh package. By isolating helper functions and raw storage behind private walls, modules let you refactor fearlessly. Outside callers can't poke at half-finished internals. Friend visibility opens a side door only for explicitly named collaborator modules. Useful for upgradable patterns. We'll meet in Module 3. When you declare a module, the first token is its on-chain owner address. During SUI client publish, the CLI rewrites 0x0 placeholders with the package address returned by the network, so you don't hardcode secrets into Git. To reuse code, reach for the use keyword. Import a single item, add to keep the namespace tidy, or self to bind the whole module under its original name. You can even alias long paths. Use 0x1 : vector as vec semicolon. Because addresses appear in every path, two different packages can safely ship a math module without collisions. Move borrows familiar visibility levels, then adds one tailored to blockchains. A plain function, no modifier, is private and invisible outside its defining module, perfect for utility helpers. Mark a function public and sibling modules may import and call it, but end users still can't trigger it directly. The entry keyword elevates a public function to a transaction endpoint. Wallets and SDKs can now encode it into a payload. Because entry functions form your contract's public doorway, the compiler enforces stricter rules. They must not leak internal state through return values, and if they touch on-chain resources outside parameters, they list those types in an acquires clause for full transparency. Move eschews type inference entirely. Every parameter and return type must be spelled out, which helps audits and the prover. Functions can hand back multiple values with a single tuple, ideal for get both sides queries. Borrowing is explicit. An ANT promises only to read, whereas emot t grants write access but forbids aliasing while the borrow is live. Generics work too. Attach ability constraints, t, store, so the compiler knows your type parameter, support storage operations. Constrained generics keep APIs flexible without sacrificing safety. The token module you'll build in a moment relies on exactly this feature to let any storable resource pass through a generic transfer helper. On SUI, a failed assertion doesn't crash halfway. It cancels the entire transaction and reverts state to the pre-call snapshot. Use that guarantee. Gate every precondition with assert. Then encode a descriptive constant like Emax supply. Reviewers instantly see business rules in the constant list. Design-wise, resist the urge to stuff unrelated ideas into one file. A focused module is easier to audit and upgrade. Finally, prove your intentions with scenario tests. Simulate the happy path and expected failures. The minute you add an assert, write a test that hits it, ensuring error code stays stable for front-end logic. Meet the first real module of our project. SUPAL point is the atomic loyalty point, a resource containing an amount field so future upgrades can bundle points in one UID. Because unbounded minting would trash tokenomics, we introduce a mint cap. Only code that holds or borrows this cap may call the private mint to helper. The package creator will publish exactly one cap and guard it in cold storage. Constants sit under a dedicated heading. Max supply will come into play when we add a total supply counter in lesson 2.2. Finally, airdrop talks self is an entry function. Any wallet can grant itself points during beta testing. Notice the acquires mint cap clause. Transparency first. Compile now and the skeleton passes, though the supply check still awaits the next lesson.